Hi guys, my name is Boris and I'm a computer engineering student at the Technical University of Berlin. And on this channel I want to talk about things that I have learned and might bring you value, general educational topics and lifestyle ones. Today I want to talk about differences between computer engineering and computer science. We all have heard this phrase that computer engineering is a combination of computer science and electrical engineering. But what does that mean in terms of courses in the actual programs? To give a better insight regarding this question, I would like to look at example programs, namely the ones at my uni, the TU Berlin. Of course, this doesn't translate one-to-one to every other uni or college, but this should give a good overview and in most cases will be fairly similar. Or you are just interested in the TU Berlin specifically. My earliest videos where I go through each semester of my computer engineering program go pretty in depth into the actual content of the courses. If you want to see that or are interested, I will link the playlist up in the info card above. I would still like to apologize a bit for the not ideal quality. But enough talking around. Right off the bat, if we put the two lists of courses in the first semester right next to each other, we can see several similarities. I have solved them like this to resemble a recommended study plan. Right in the first semester, we see that almost everything overlaps. For example, computer organization, where you cover the fundamental technology of computers, like the binary and hexadecimal system, Boolean logic, and the basics of a single core processor. Then there also is introduction to programming, where you learn to code in C and about sorting algorithms, and also Calculus 1 and Linear Algebra 1. All of those are fundamentally important courses in both programs. In computer science, your first semester starts off a bit easier, since there's only one more 3-credit course called Computer Science Propedeutic, or however you pronounce that, which basically just covers how to scientifically work in the field of computer science and how to get the right mindset for problem solving. Computer engineering, on the other hand, starts a bit more rough, with a course called Fundamentals of Electrical Engineering. This course can be tough for a lot of students because it involves a lot of maths and physics, but in my opinion it is really interesting. So up until now they are basically the same, but computer engineering is a bit more difficult. If we look at the next semester, we can see a few more differences. Both programs include a course called System Programming, which covers a few operating system concepts. For example, if you're scheduling algorithms that are used to schedule different processes or rather threads, or more similar OS related topics like resource allocation. Then there is the course on algorithms and data structures, aka your generic big tech coding interview course. The name speaks for itself, I would say. At this point we can see the changes. Computer science now really gets into its territory with courses on data science and theoretical computer science. Formal languages and automatons has its topics literally in the name. You not only cover formal languages in the Chomsky hierarchy, but also logic, proofs, and discrete structures like relations, functions, and more. The course Discrete Systems has some similarities to the previous course, but covers more abstract mathematical models like monoids, groups, trees, graphs, and a bit more of combinatorics. These things look scarier than they really are, which is actually the case for most things you'll learn in uni. Finally, there's a course on information systems and databases. Here you basically learn about SQL, a bit UML, and about the client-server model. Of course, there is a bit more to it, but this should give you a good feeling. Looking at computer engineering, we'll see Calculus 2. That mainly consists of Calculus 1 but in higher dimensions. We then have the course on digital systems. That again covers things like the binary and hexadecimal system, Moore and Mealy automatons, Boolean logic, but also how to implement this logic with transistors on a conceptual level. Then electrical networks is again one of the harder courses for most of the students. You might see a trend that the electrical engineering courses are considered a bit harder. You again cover what the name suggests. You simply said learn methods to analyze electrical networks, but with that also about the representation of current and voltage in form of complex numbers and locus curves, Fourier and Laplace transformations and more. So again, quite a bit of maths. Now we are at the point where they differ quite a bit, but we still have one course that overlaps: computer networks and distributed systems. Again, the name speaks quite for itself. But buzzwords would be something like the core ring, the TCP/IP or OSI model, the REST API, and so on. Computer science now fully commits to theoretical computer science, with courses, for example, solely on logic and one on computability and complexity theory. It also has a course on the different software architectures and best practices for programming. And it also has a course for computer graphics, which weirdly enough is called Wissenschaftliches Rechnen in German, which literally translates to scientific maths. But if we now look at computer engineering, we'll see the opposite. There is a lab course for computer architecture, where you will learn how to implement processor components in a hardware description language, for example VHDL. Then there is a course on signal processing and how to abstractly work with systems. Signal processing typically includes a lot of maths again: Fourier transformations, Laplace transformations, convolutions, and so on. But it is really incredible what we can derive from signals that are just waves through a bit of maths. Speaking of maths, you will also have a whole maths course on transformations and also partial differential equations. Integral transformations and partial differential equations. Doesn't that name alone just sound cool? Finally, you will have the physics course in this program covering semiconductors. You will be going pretty deep into physics and possibly getting lost. In my opinion, this course is the most difficult to understand, starting from band theory and going all the way up to the design of metal oxide semiconductor field effect transistors, or for short, MOSFETs. Continuing from here on, you can see that the next semester of computer science is very open, so you can choose specific courses yourself. You do have limitations, for example, where you have to choose a 6-credit computer engineering course and a further 6-credit theoretical computer science course. You then also have a catalog of courses that are considered a lab course or a practical course, where you basically work on little projects concerning a specific topic like data science in Python and R or cyber-physical systems. You have only one real mandatory course on stochastics this semester. So you see, computer science has a lot more freedom of choice. Computer engineering, on the other hand, can also choose some courses freely, but we'll get to that in a bit. Looking at the 4th semester, we can see courses like a hardware lab course that is literally just the same as your computer architecture lab course, but a bit more sophisticated. Then you have another electrical engineering course where you start learning how to design circuits. This again is more maths than you may think. You now can choose one course out of 3: Fundamentals of Theoretical Computer Science, a course on more statistical signal processing, and a course on electromagnetic fields. I personally chose the computer science course. Now, over the span of the 4th, 5th, and 6th semester, you have a range of 24 to 27 credits for computer engineering to choose a computer engineering or computer science related course, whilst with computer science, you have 27 to 33 credits to choose a computer science related course. There are quite a few to choose from. This means you have more options to choose from in your computer engineering degree, but really overall you can actually take less. Note, large parts of the computer science catalog are also available for computer engineering. Both then also have an option to choose any course they want that are offered by the uni or even other unis. Computer engineering hereby again has less credits though. So we are almost done with all the real mandatory courses. At least in computer science you only have one left, which is basically ethics in computer science. Computer engineering, on the other hand, has 3 more mandatory courses, one of which is arguably the hardest one. In this course, you write your own operating system, which is really interesting, but a lot of work. Then there actually is one more course that overlaps with the computer science program, which they had in earlier semesters, namely the one that covers the software architectures and the best practices for programmers. Finally, electrical engineering has a course on measuring technology, which is a bit statistics and more electrical engineering. To finish off your degree, both programs obviously require you to write the actual bachelor thesis. So to summarize, computer engineering and computer science are quite similar, but mainly in the beginning. Computer science focuses then more on theoretical computer science and data science, whilst computer engineering goes more into heavy maths and obviously electrical engineering and physics. But after all those mandatory courses are over, in your computer engineering degree you can take several computer science classes and vice versa. At least that's what I did. Now, which one of those two programs is better? Well, obviously computer engineering. But now, to be a bit more professional, if you really like understanding physics and electrical engineering, go for computer engineering, obviously. But if you really can't be bothered with all this engineering-related maths and physics, by all means, go for computer science. Okay, I hope this comparison could help you get a better feeling for what the differences can be in a computer engineering and computer science program. And if it did, please like this video and subscribe. If you want to see what a computer science or computer engineering bachelor thesis can look like, I will link you up the video right here where I talk about my bachelor thesis. And you can then watch the following videos if you enjoyed it. And yeah, with that said, as always, thank you very much for watching, and I'll see you guys in the next one. Bye!